Hi everyone. So today we're going to finish off with our work on lines in 3D, and then we're going to move on to planes. Okay, so we've already gone through how we describe lines in n-dimensional space. Now we're going to look at some different types of lines. Okay, or some classification of them. So number one, we can have intersecting lines. Okay, so let's say in 3D, we have some line going this way, and then some line going this way, and then we've got ourselves some intersection point, let's say at P. Okay, so we say that these lines are intersecting if there's a point that is common to both of those lines. Then we've got a special case of intersecting lines, and that is perpendicular lines. So number two. Perpendicular lines. So this is where they are intersecting, but also the angle between them is 90 degrees. So again, we've got some line going this way, some line going this way. They intersect at point P, okay, in three-dimensional space, but also the angle between them is 90 degrees. Okay, or pi over 2 radians. Okay, so we say that those are perpendicular lines. Then number three, we get parallel lines. Okay, so this is where we've got parallel lines. We've got two lines like this. Okay, and then there's no intersection between them, and they are both moving in the same direction. So we've got this line moving in one direction, and we've got another line also moving in the same direction, but they're not coinciding. Okay, so they're separate from each other and both moving in the same direction. Okay, so that's parallel lines. And number four, we have the case where it's none of these. Okay, so it's not intersecting, not perpendicular, not parallel. We call those skew lines. Okay, so this is where we have one line, let's say, going this way, and then another line like this. Okay, so here we have the black line is above the green line. Okay, but they're not intersecting with each other. There's some distance between them. So if you imagine in 3D space, you've got a green line going and a black line running above it. So they would intersect if they lie on top of each other, but there's some distance between them. Okay, so they're not parallel, they're not intersecting. We call them skew lines. So not parallel, not intersecting. Yeah, we call them skew lines. Okay, so let's have a look at some examples with these. So we'll start off with intersecting lines. So given two lines, we want to find, is there some point P that is common to both of them? Okay, so example one. Okay, let's say we have line 1, and this is given by 130 plus t, which is our line parameter, 3 minus 3, 2. And we've got some line L2, and this is given by 402, plus we need a different parameter because it's a different line, so let's call it lambda, and then minus 3, 3, 0. Okay, so we've got two lines in 3D space. We want to see, is there some intersection between them? So if there's an intersection, it means that there's some t value and some lambda value where these two are equal, giving the same point. So let's make the 2 points equal. So we have 130 plus t 3 minus 3, 2. So at some point at t, this must be equal to 4, 0, 2 plus lambda minus 3, 3, 0. So again, these must be equal at some point p, like we had in the previous diagram. Okay, so let's add these two things together on both sides and see what we get. So on the left-hand side, if we add the components, we get 1 plus 3t, 3 minus 3t, and 0 plus 2t. And on the right-hand side, we get 4 minus 3 lambda, 0 plus 3 lambda, and 2 plus 0, so just 2. Okay, so we get 3 equations, because if we look at each component, we have this x component must be equal, the y components must be equal, and the z components must be equal. Okay, and then that will tell us, that will give us 3 equations that we can work with. So number 1, for the x components, we get 1 plus 3t is equal to 4 minus 3 lambda. For x, we have 3 minus 3t is equal to 3 lambda. That's for y. So that's for x, that's for y. And we have a third equation, 2t is equal to 2. And remember, that's for z. So now what we want to do is find a value of t for the first line and a value of lambda for the second line such that the two are equal. So we've got 3 equations, 2 unknowns. We need to try and solve this. So let's look at equation 3. We've got 2t is equal to 2. Divide both sides by 2, we have t is equal to 1. Okay, so if t is equal to 1, we can use that to substitute in the other equations to try to figure out what lambda is. So let's sub it into equation 1. So from equation 1, we have 1 plus 3 times t, so 1 plus 3 is equal to 4 minus 3 lambda. Okay, 1 plus 3, that's going to be 4, is equal to 4 minus 3 lambda. Canceling the 4 on both sides, we get lambda is 0. So from these 2 equations, we see that t is 1 and lambda is 0. Now you can substitute these into all 3 equations and we see that it is consistent. So sub these into all 3 equations to check for consistency. Okay, so remember from our work on systems of equations, we want things to be consistent. Okay, but in this case, you can check it is consistent. So we've got t equals 1, lambda equals 0. Let's see what the point is. So if we look at our first line and we substitute t equals 1, what do we get? So this at t equals 1, this is going to give us a point. So we're going to have 1 plus 3, so that's going to be 4. 3 minus 3, it's going to be 0. And 0 plus 2, that's going to be 2. Okay, and let's just check for the second line. If we substitute lambda equals 0, what do we get? We should get the same answer, so let's just see. We're going to have 4, 0, 2. Okay, so that's just an extra check to see that we've got the right answer. So at both values, t equals 1, lambda equals 0, we get the same point. So this must be the unique point of intersection. Okay, 4, 0, 2. Therefore, L1 and L2 intersect at 4, 0, 2. Okay, so that is the unique point of intersection. Okay, any questions on this example? Okay, let's have a look at the next example then. Example for the second case, example 2, we've got a line L1, and that's given by 130 plus T 102, and L2, which is going to be 402 plus lambda, because it's a different line, need a different parameter, minus 2, 1, 1. Okay, and the question is, are these lines perpendicular? Yeah, we can just say perpendicular. Okay, so how are we going to do this? Well, we can do a rough sketch of what's going on, and then from that, we can get an idea of what to do. So let's say the first line, L1, is doing something like this, L1. And the second line, maybe it's doing something like this. That's L2. We want to see, is the angle between them 90 degrees? Okay, if the angle between them is 90, then that means they're perpendicular. Okay, so how are we going to do that? Well, we know how to find the angle between two vectors, and we also know how to check if that angle is 90. So let's find two vectors, one along L1, one along L2, and find the angle between them. Okay, so let's say there's a vector along L1 that looks like this. And there's a vector along L2, and it might look like that. Okay, if we've got this vector along L1, let's call it A. And the vector along L2, let's call that B. If the dot product between them is 0, then we know that the lines are perpendicular to each other. Okay, because that means the angle is 90. So if A dot B is 0, then the angle is 90. So this angle here would be 90. And so L1 would be perpendicular to L2. Okay, so how do we find these vectors A and B? Well, we already know what they are, because remember how we construct these lines? We find a point along the line, and then we provide a direction to the line. So this first vector here, 130, that's a point on the line. The second vector, 102, the one with the parameter, that gives us the direction. So in this case, this second vector here, this is our A vector. That's the direction of the line. Similarly for line L2, the first vector, that's just any point along the line. The second vector, the one with the parameter, that is the direction of the line. So that's going to be our B vector. So that's B vector. Okay, so that's how we find the directions of the two lines. It's the vectors that are along with the parameters. So let's do the dot product and see if it's 0 or not. So A dot B is going to be the A vector, 102, dotted with the second vector, minus 2, 1, 1. And we need to see, is this 0 or not? So this is going to be 1 times minus 2, plus 0 times 1, plus 2 times 1. So that's going to be minus 2, plus 0, plus 2, that's 0. So the dot product is 0, which means the angle is 90, and so they are perpendicular to each other. Therefore, L1 is perpendicular to L2. Okay, because the angle between them is 90. Okay, Any questions on this example? Okay, let's have a look at the third case. Okay, so example 3 for the third case. So this is when lines are parallel. So let's say we have a line L1, and this is given by -2, 3, 1 plus T 1 minus 2, 1. Okay, so that's our line L1. We've got a line L2, and this is given by 0 to 1 plus lambda, because we need a different parameter, -2, 4, -2. Okay, and the question is, are these lines parallel? Okay, and again, we can draw a little rough diagram of what's going on to see what we need. So let's say we've got L1, maybe it's doing something like that, and L2, if it's parallel, it should be something like this. Okay, so it runs next to the line. So we've got L1 and we've got L2. Okay, so how are these going to be parallel? Well, we can look at it in terms of the direction vectors for L1 and L2. So again, we just pick some points along the line. Let's say, let's do a different color. Let's say this point here and this point here. Okay, what we want to do is find the direction vectors at these 2 points. So let's say for the line L1, the direction vector is something like that. And remember, if we take multiples of this direction vector, then we move up and down the line. Okay, we showed that last time. And if we look at L2, we can have another direction vector. Maybe it's a bit longer, but it points in the same direction. And again, if we take multiples of that direction vector, then again, we move up and down that line. So when would these 2 lines be parallel? Well, these 2 lines would be parallel when these 2 direction vectors are pointing in the same direction. Okay, because then the lines move along with each other. So these 2 lines are parallel when the 2 direction vectors are parallel themselves. Okay, so when the direction vectors are parallel, then the lines are parallel. Okay, so when are vectors parallel? Well, 2 vectors are parallel if they are pointing in the same direction. Now, they could have different lengths. Okay, you see the blue one is shorter than the green one, but they're still in the same direction. So if we're not worried about the lengths of the vectors, then we just know that one is some multiple of the other. Okay, that means they're in the same direction. So in this case, the blue one is some multiple of the green one, or the green one is some multiple of the blue one. It goes either way. So if we call this one A and this one B, we know that A must be proportional to B. Okay, or in other words, A is some multiple, let's call it K, of the B vector. So A is proportional to B, or we can say A is some multiple of B. Okay, that's what we mean by 2 vectors being parallel to each other. So let's look at this example here. We've got our 2 direction vectors, A and B. A is for the first one, so that's going to be our A directional vector. And then we've got this lambda, this other vector, so that's going to be our B directional vector. Okay, so let's see if they are proportional to each other. So is A proportional to B? Well, we can write down A. A is 1 minus 2, 1. And B is minus 2, 4, minus 2. And we can see that, yes, there is a constant multiple difference between the two. If we take A and we multiply it by minus 2, then we get B. Or in other words, if we take B and we divide it by minus 2, we get A. So you can look at it either way. But here we get, or we have B is equal to minus 2 times A. So A is proportional to B or B is proportional to A. It doesn't matter which way you do it, but that means that these two vectors are in the same direction. So A and B are in the same direction. Because they're just multiples of each other. And so L1 is parallel to L2. And we can just use that double slash line to show parallel. Okay, like you would have done in metric with parallel lines. Okay, so that's how we can show if two lines are parallel. So if we can't show this, where one is a multiple of another, if we can't do that, that means they're not parallel. Okay, any questions on this example? Okay, let's have a look at the last example on skew lines. Okay, so this is example 4. Okay, so this is with skew lines. And we know with skew lines, they are not intersecting and not parallel. So there's two things that we need to check for that. Okay, so let's say we have lines L1. That's given by 2, 2 minus 1 plus t, and then our direction vector 3, 1 minus 3. And L2, that's our second line, is 1, 0, 1 plus lambda, because we need a different parameter, because it's a different line. 6 minus 4 and 9. Okay, so we've got these two lines, and the question is, are these lines skew? Yeah, and we know skew, that means not parallel, not intersecting. Okay, so we need to check those conditions. So again, let's just draw a little picture of what's going on so we can better understand this. So we've got some line L1 going this way, and we've got some line L2 going like this. Okay, and that little gap just means that L1 is above L2. Okay, so there's no intersection over there. So it looks like they're intersecting, but L1 is actually above L2. So that they're not touching each other at that point. Okay, so that's what it means to be skew, but we need to check that. So first, let's see if they are parallel or not. So we've got our two direction vectors, the vector linked with the t and the vector linked with the lambda. Are they parallel vectors or not? So let's say this first one's A, the second one's B. Okay, do we have A being proportional to B. Okay, so is there some multiplier that we can multiply A by to get to B? Okay, any ideas? Okay, is there a way to get from A to B using some multiple? Everyone's still sleepy today. Okay, so no, there isn't. We can't have a multiple of A that gives us B, so they are not parallel. Okay, so they're not parallel. What about an intersection point? Is there some point where these two are equal or not? So let's say L1 is equal to L2. So 2, 2, minus 1 plus t times 3, 1, minus 3. This must be equal to, or should be equal to, if they intersect, we need to check that. 1, 0, 1 plus lambda 6 minus 4, 9. Okay, so let's add up the two vectors on both sides. So on the left-hand side, we get 2 plus 3t, 2 plus t, and minus 1 minus 3t. On the other side, we get 1 plus lambda times 6, or you can write it as 6 lambda if you want. Okay, then we get 0 minus 4 lambda, and then 1 plus 9 lambda. Okay, and if these two vectors are equal, then each of the components are equal. So we get 2 plus 3t is equal to 1 plus 6 lambda. That's for x. We get 2 plus t is equal to minus 4 lambda. That's for y. And for z, we're going to get minus 1 minus 3t is equal to 1 plus 9 lambda. Okay, that's for z. Okay, so what we want to do is check to see if the system is consistent or not. So is this system consistent? Okay, so let's try and solve the system to see if it's consistent. Okay, so we can rewrite this as 3t minus 6 lambda is equal to 1 minus 2, so that's minus 1. Number 2, we can write it as t plus 4 lambda is equal to minus 2. And number 3, we can write this as minus 3t minus 9 lambda is equal to 1. And then from this, we can get ourselves a matrix equation. So we can write this as 3 minus 6, 1, 4, minus 3, minus 9, augmented with minus 1, minus 2, and 1. Okay, so I'll leave that for homework to check if this is consistent or not. If it is consistent, that means there is a solution. So we have a point of intersection. If it is not consistent, then we don't have a point of intersection. Okay, so I'll leave that for homework to check. Okay, so homework, check if this is consistent, and then from that you can conclude if the lines are skew or not. Okay, are there any questions about what we've gone through today? Okay, so give the homework a try, and then I will upload the solutions later today, and then you can compare that with yours. Okay, if you do have any questions, you just let me know on the WhatsApp group, or you can email me. And remember that the tutors are also available to help you out. Okay, and also remember that test 1 is coming up as well. Okay, so if you have any questions about test 1, again, you can ask me or the tutors for help. I've got a question here. So on number 3, I think equal 2. What's that on number 3? Where's number 3? Wait, did I make a typo somewhere? Last line for number 3. Where's that? This bit, this equation here. Yeah, -1 minus 3t equals 1 plus 9 lambda. I don't see where the problem is. Did I make a typo somewhere? Hello? Okay, maybe you can explain it on the WhatsApp group afterwards. Okay, so I'll upload the video to Learn and YouTube, and then you can ask me questions later on. Okay, bye everyone.